and we're going to do some fun stuff here. I don't know about fun, but we're just going to kind of go through some notes. These are going to be on day 9.1. So if you want to just follow along the video, or if you want to print off your own and follow along, you can do that. We're not going to waste a whole lot of time. We're going to get going here and get this going. So transformations, I'm going to be honest with you folks. Right here are your kind of objectives for this lesson. I have two acronyms that I use a lot of times when dealing with transformations, and that is the acronym IHOP overs. Okay, so the I in IHOP stands for inside, which would be inside my parentheses, inside the absolute value, inside the square root, things of that nature. Affect the graph horizontally, which means left to right, left or right I should say, and opposite usually of what you think. If whatever is done is outside of your parentheses, absolute value, square root, things of that nature, then it will affect it vertically, meaning up and down, the same as what you think. So let me show you how this kind of works. And I'm going to start off right here looking at graphing the quadratic in this form. Now, first they want us to graph what's called the parent function, which is just x squared. So if I just did a little t-chart of values here for x and y, say I pick my fab 5, -2, -1, 0, 1, and 2, and this of course is for x squared, I'm plugging -2. -2 squared is 4. Plug in -1, -1 squared 1. Plug in 0. 0 squared 1, 0, 1 squared 1, 2 squared 4. Oh yeah, we know what this looks like. 1, 1, 2, 4, -1, 1, -2. Oh yeah, this is a parabola. Looks very much like that. Okay, there's our parabola. We call it a parabola. Every x squared graph looks like that. It's called the parent function because just like you have parents, and you're a little bit different than your parents, the parent function is where it begins, and then things change a little bit. So right here, as I look at x squared plus 3, I would ask you, is that plus 3, is that inside parentheses, absolute value squared, is that inside or is it outside? Well, you might say, I don't know. Take a look down here, number 3 real quick. Take a look at this guy, x minus 2, quantity squared. Is that inside or outside the parentheses? Well, this one hopefully you say is inside the parentheses, which therefore would make this one outside the parentheses. So outside, vertical, so we're going to affect our vertical up and down, the same as what we think. So plus 3 means I'm going to take my y values and add 3. So 0 plus 3 is 3. This is 1 plus 3 is 4. 1 plus 3 is 4. 4 plus 3 is 7. 4 plus 3 is 7. And there is my new parabola. Notice it looks just like my original, or the parent, just shifted up 3. If you look here, that's outside. Again, vertical the same, so shift everything down 4. So 0 minus 4 is -4. 1 minus 4 is -3. 1 minus 4 is -3. 4 minus 4 is 0. 4 minus 4 is 0. And there is our new parabola. It looks just like our original, just shifted down 4. So outside with addition or subtraction is a shift, up or down. Now let's take a look here. Again, my acronym is IHOP, which stands for if it's inside the parentheses, it's going to be horizontal, opposite of what you think. So here we go. This is inside, so that's going to affect it horizontally. So again, our original 0, 1, 1, 2, 4, -1, 1, -2, 4. That's our x squared. We graphed that. Right here is our table of values we used for that. There's our parabola. That's where we began. -2 on the inside is a horizontal shift. Opposite of -2 would be to the right 2, 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 and there is our new parabola. Look, it looks identical to our original, just shift it to the right to right because it's opposite, because it's inside the parentheses, we go opposite. Here, inside the parentheses, opposite of plus 3 would make it to the left 3. So again, we start our original, left 1, 2, 3, left 1, 2, 3, left 1, 2, 3, left 1, 2, 3, left 1, 2, 1, 2, 3, and there is our parabola. It's just like the original, shifted to the left 3. All right, here we go. So next step, or the next one we're do, look, it has an inside and an outside. What does that mean? It means you do both. As an order of operations, always work inside to outside. It's always best that way, okay? So work inside to outside. So inside, so an x squared, that's a parabola. That looks like this. 2, 4, negative 2, 4. There's our original right there. Inside left 2. So how come I went left instead of right? Because inside is horizontal opposite. Opposite of 2 is left 2, left 2, left 2, left 2, left 2. Now you can draw the parabola in, but then you're going to take that parabola and go outside vertical same. So shift it down 1, 2, 3. Shift it down 1, 2, 3. Come down 1, 2, 3. Come down 1, 2, 3. Come down 1, 2, 3. And there is our new parabola. It looks just like the original, but shifted to the left 2 and down 3. All right, now what? And that's so. Just to let you know, anytime that anytime there is an add or subtract, that is a shift. So shift comes from either adding or subtracting a number. Okay, and we can add or subtract inside the parentheses or outside the parentheses, and we just do inside, opposite, horizontal, outside, vertical, same. Shift is when we just take the whole graph and move it left, right, up, and down. Let's take a look here. Now we're going to look at multiplying by a number. When you multiply or divide, okay, you multiply or divide, that's going to do what's either called a stretch or a shrink. Okay. Again, we're still going to follow our IHOP overs, inside horizontal, opposite, outside vertical, same. So again, x squared, we already have that graph. We know what that looks like now. We should be able to graph that fairly quickly. Those points, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. That's our parent. Now this 2 is on the inside or outside? It is on the outside, vertical. Same, so I'm going to take all the y values, multiply them by 2. 0 times 2 is 0. 1 times 2 is 2. 1 times 2 is 2. 4 times 2 is 8. 4 times 2 is 8. And there is my new graph. Notice that it got a little bit skinnier because it got vertically stretched. Okay? Take a look here. That 1/2 is on the outside. Vertical, the same. So I'm going to take all the y values and multiply them by 1/2. That's going to vertically shrink them. So this point is going to be at 1/2. This point is at 1/2. This point that was at 4 is now at 2. Point that was at 4 is now at 2. And there's our graph there. Notice that it's the same as the original, just vertically shrunk. All down by 1/2. All right? Now, let's take a look here. That's when you multiply or divide. Divide is like multiplying by a fraction that's less than 1. Negation. If we have a negative sign out front or inside, negation, that is going to flip the graph or reflect it. Okay? So if we were to look at our original, x squared, we know that, 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. There's our original. The negative on the outside is going to flip it, and it's outside vertical, so it's going to flip. What's going up must go down. So what's going up must come down. So if you want to, you could think of multiplying the y values by -1. So 1 times -1, -1, 1 times -1, -1, 4 times -1, -4, 4 times -1, -4, and whoo, there it is. Now look here, we're going to multiply by -2. So in other words, you could take these values, multiply them by -2, or you could take these values of it's already being flipped with the negative and multiply by 2. Either way, if I take 1 multiplied by -2, I get -2. 1 multiplied by -2, -2. If I take 4 times -2, I get -8. 4 times -2, -8. So what happens? It vertically gets stretched, and it was flipped because the negative flipped it, the 2 stretched it. Look at -1/2 x squared. So again, I could take this value of the negative, because it's flipped, and then half it, so it'd be -1/2. This value, -1, and half it, -1/2. The value at -4/2 would be -2. The value of -4/2 is -2, so there it is. And there's our new graph. Again, looks just like the original, flipped though, and vertically shrunk. All right, we're moving right along. Okay, I think you guys can probably do A and B all by yourself. We're going to move down here to graphing in quadratic form. Okay, so there's 2 ways to do this. One of them is to get it into what's called vertex form. And if you look right here, this is vertex form. Right here, that's vertex form. The reason they call it vertex form is because that the vertex is staring you right in the face. So the vertex of the equation is HK. Notice that it's opposite of what's inside, the same as what's outside. Opposite of what's inside, same as what's outside. That's vertex form. The only way to get in vertex form is to do this thing called completing the square, which I'll show you. I think you guys know this. Quadratic graphs are called, we've been saying it quite a bit today, a parabola. They either open up if A is positive. So if A is positive, it'll open up. It's going to open down if A is negative. So in other words, positive people go up, negative people go down. If A is positive, it goes up. If A is negative, it's going to open down. There's a vertical line passed through the vertex called a line of symmetry. That means it's the same on the right and the left-hand side of that line of symmetry. So, one of the ways to do this is to find the vertex and then determine if it's opening up or down and kind of go from there. So, let's go ahead and complete the square, and then I'll show you the other method here in just a second. So here's our equation. We've completed the square before, so if you remember correctly, the first thing we do is we get rid of that last number. So instead of +3, I subtract 3 over. That would give me f of x minus 3 equals x squared plus 4x. Then I take the middle term, divide by 2, and square it. 4 divided by 2 is 2. 2 squared is 4, so I add 4 right there. What I do to one side of the equal sign, I have to do the other, so I add 4 over here. That's going to be f of x plus 1 equals, the whole reason I did this is so that I could write it into factored form, which this is going to be x and x plus 2, which really is just going to be x plus 2 squared. I want to subtract the 1 over, giving me f of x equals x plus 2 squared minus 1. There's your vertex. Vertex is opposite of what's inside, the same as what's outside, -2, -1. So -2, -1. I do know the graph opens up because A is positive. If I found one other point, then I could use the axis of symmetry, which is going to go right through -2, x equaling -2. Use that axis of symmetry. So if I find a point here to the right, say at -1, if I put in -1, I get -1 squared, which is 1, plus 4 times -1, which is -4, plus 3. 1 plus -4 is -3. -3 plus 3 is 0. So -1, I'm at 0. So if I come this way, I'm at 0. Now, if I plugged in 0, I would have got 0 squared plus 4 times 0 plus 3, which is just 3. So at 0, I'm at 3, which means at negative 4, I'm also at 3. That's how that axis of symmetry works. And there is my graph. The domain in this case would be negative infinity to infinity. The range, how far down I go, would be negative 1 up to infinity. Notice I put a bracket on negative 1, because it does make it all the way down to negative 1. Now, I'm going to show you another method, okay, to draw this graph. It's really not too bad. If you just trust me on this, there's an equation out there for the x value of the vertex, which is negative b over 2a. Then once I find that x value, I can find the y value by taking negative b over 2a, whatever that value is, and plugging it into my function. So let's just see what that looks like here. X equals negative, what's b? Well, if you remember, a is the term in front of x squared, b is the term in front of x, and c is the last term here. So negative b, so that'd be negative 4 over 2 times a, which in this case is 1. So that's negative 4 over 2, which is negative 2. The x value of the vertex is negative 2. Notice right here we said the x value is negative 2. Now we just take negative 2 and we plug it in. So in other words, we take f of negative 2. That's going to be negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4 plus negative 8 plus 3. 4 plus negative 8 is negative 4 plus 3 is negative 1. My vertex is at negative 2, negative 1, just like I got right here. I know the axis symmetry, and then I found points by just plugging in some values, and we're there. So let's go ahead and take a look at this on number 8. Okay? So if I was telling you to, go ahead and graph this, you could complete the squared. It is a little bit trickier, but you take f of x equals negative 2x squared plus 4x plus 1, subtract the 1 over, so f of x minus 1 equals, factor out the negative 2 first, get x squared minus 2x. We then take the middle term, negative 2, divide by 2, and square it, which is a positive 1. But you didn't really add 1, you added 1 times negative 2, which is a negative 2. So you have to add that over here on this side, which is a negative 2. So that gives us f of x minus 3 equals negative 2. The whole reason I did this, so I could write it as in factor form, which is going to be x minus 1 quantity squared. Add the 3 back over. So I get f of x equals negative 2 times x minus 1 squared plus 3. Which means my vertex is going to be at 1, 3. There's my vertex. Now, let's do it the other way. If I let x equal negative b, which is 4 over 2 times a, which is negative 2, negative 4 over negative 4 equals 1. So the x value of the vertex is 1. Now I just take 1 and plug it in. So I take f of 1. That's going to be negative 2 times 1 squared plus 4 times 1 plus 1. That's going to give me negative 2 plus 4 plus 1. Negative 2 plus 4 is 2 plus 1 is 3. So my vertex is at 1, 3. Either way, I get the vertex out of 1, 3. That means the axis of symmetry is x going to equal 1, equals that x value of your thing. So I have a point at 1, 3. I do know that it opens down, so it should be looking something like this. If I plug in 0 here, I get 0 plus 1, which is 1. So at 0, I'm at 1, which means my axis symmetry here. So at 2, I'm at 1. If you want, plug in another point like 3. So that'd be negative 2 times 3 squared plus 4 times 3 plus 1. 3 squared is 9 times negative 2 is negative 18 plus 12 plus 1. Negative 18 plus 12 be negative 6 plus 1. Negative 5, so at 3 I'm at negative 5, which means at -1, I'm also at -5. And there's my parabola. So my domain is -infinity to infinity. You're going to find out the domain is always the same. And the range, in this case, is -infinity up to 3. Bracket on the 3. Okay, so let's go ahead and just talk really quickly. What does each value in the equation represent? Well, this A represents a vertical stretch or shrink. And it also represents whether it opens up or down. So in other words, if it's flipped and opening down or if it's opening up. H here represents a horizontal shift or the X value of the vertex. And then K, that is our vertical shift or the Y value of the vertex. Okay? So now they want us to write an equation in this format. Well, we know H and K are the vertex, so here's our vertex, 2, 3, so just plug them in. So f of x equals a times x minus the x value, which is 2, squared, plus the k value, which is 3, or the y value, which is 3. That's now going to give us this. To get A, we need one more point. If they only gave us another point on the graph, if they only had given us another point on this graph, if they did, it's right there. There's our x, there's our y, plug it in. -5 equals, f of x is the same thing as y. A times the x value, which is 0, minus 2 squared, plus 3, so I'm going to subtract 3. It's going to give me -8 equals a times -2 squared, but -2 squared is 4. So that's a times 4 equals -8. Divide by 4. I get a equals -2. So now we can rewrite this equation by plugging -2 right in there for a. So I get f of x equals -2 times x minus 2 squared plus 3. There's the equation. Folks, good luck. Email me if you have questions on your homework, and hope you're having a wonderful day. Maybe I'll do a homework problem later, and I'll post it then. But I hope this helps, and we're beginning, so we'll just keep getting better from here. Have a good one. See you guys. Bye. Hey, are you okay? Hello? I heard you, but then you're gone. Hey, are you okay? Oh, good. What's up?